Hi, everyone. Okay, this is intro lecture 2 because we had to miss class because of the power outage. So let me share my screen. Okay. Should all be able to see that. Okay, so this section is what we would call psychobiology. So it's the merging of the two fields of psychology and biology. And again, it's an overview. We're going to start with the basic unit of the nervous system, and that's the neuron. It's what receives signals from all of our sense organs, and then the neurons travel that impulse all the way to the brain works on it, and then uh, the brain decides what it's going to do, and then impulses are sent from the brain to different parts of the body based on what is necessary for um, whatever function they're doing. And what's interesting is that no two neurons touch. They communicate via a chemical called a neurotransmitter that's passed through the synapse. So let me back up a little bit and let's just talk about neurons first before we get into the heat of this. So, and also don't get hung up on the numbers because the numbers are pretty big. So we have sensory neurons, motor neurons, and interneurons. Sensory neurons, of course, are taking the information from our senses. So we have visual, auditory is hearing, gustatory is taste, olfactory is smell, and then of course tactile, which would be touch. They travel from those sense organs to the brain and back to wherever they need to go via the motor neurons, and the interneurons are the ones that connect the neurons to different parts of the body. Again, remembering no two neurons touch. When we have a whole unit that works together, we call that a brain circuit. So here's a neuron. So let's take a look at our neuron here. So these branch-like structures are known as the dendrites, and this is where information is going to come into the neuron. We have the cell body, also known as the soma, S-O-M-A. That's where a lot of things are happening, basically the brains of the operation. This long, windy thing is known as the axon. It's covered with a material called myelin, which can help the impulse travel further down this axon till we get to what's called the terminal buttons. They kind of look like ET's fingers. And it's in these terminal buttons that we have housed those neurotransmitters that are going to be used to communicate to the next neuron. So I always talk about like resting potential. This is when you're waiting. And the best way to try to explain it is think just like if you're at a football game or a game and you're going to do the wave. So like, woo, right? But you're sitting there waiting your turn. Well, that's what kind of resting potential is. Just sitting there ready to go as soon as you're called upon. And in this case, for a neuron, as soon as it fires. There's an all or nothing principle. In other words, it's one or the other. There's no happy medium in between that. And we already talked about the myelin as an insulator. People who have MS, multiple sclerosis, we know that the myelin on the axon has been deteriorating, and the more it deteriorates, the worse the MS gets. MS isn't only for old people, young people can also get multiple sclerosis. And here's a neuron activity. We'll try to do this one in class, so you can ignore it for right here. So the brain is the single most complex object in the universe. Again, we have about 100 billion neurons. Each one has about 10,000 connections. So you're talking 10 trillion connections. It's a lot of connections, a lot bigger than the Powerball, right? So let's look at our terminal buttons. Since no neurons touch, that space in between is called the synapse. If you're using an older book, you may see synaptic cleft or a synaptic gap. Both of those are still acceptable. Recently, they've been publishing books just using the word synapse, period. But all of them would be acceptable, like on a test. So the synapse is that space in between our two, the terminal button of the one neuron and the dendrites of the second neuron. And the chemicals are in these little vesicles that we have in the terminal button. And when the impulse hits, it releases the chemical into the synapse that will bind to these receptor sites on the next dendrites of the neuron that it's connecting to. It works just like a key. And when it's done doing its magic, per se, when it's done doing the connection for the next neuron to fire, that neurotransmitter is taken back up into those vesicles, just waiting, again, that waiting to fire, waiting to fire. There are neurotransmitters that are excitatory. That means it causes the next one to fire. And then there are some that are inhibitory, so it would cause them not to fire or at a slower pace. When we think of neurotransmitters, the more common ones you've probably heard of are the SSRIs, selective serotonin reuptake inhibitors. It's okay to abbreviate that. Paxil, Zoloft, Prozac. Prozac is probably the oldest. It's probably 35 years old. So it's been studied almost to death. But we also, because of that, know a lot about this drug. So it's still used today, and it's many times the first drug of choice at the lowest dose. It can take anywhere between 3 months to 6 months for it to actually take effect. And during that time, the person should be monitored completely. If it is a young adult or an adolescent, they should be watched closely. One of the bad things with SSRIs, one of the side effects is it can cause suicidal tendencies. So here you are, you have a teenager who's depressed that comes to get help, and they are given this SSRI. And in most cases, the people getting this drug are perfectly fine. But let's just say this individual has that type of reaction to it where they begin to think negatively of themselves and what's going on in their life, and they choose to end their life. So it's never been a drug that you just give and, hey, I'll see you in a year. It has to be monitored by a physician. So if we talk about the nervous system in intro to psychology, we focus more on the autonomic nervous system. So you have the sympathetic and the parasympathetic. The sympathetic is what speeds up our system. So the heart rate will go up, blood pressure, um, your breathing, the way your body consumes food and regulates hormones like cortisol, which is the stress hormone. That happens, and it happens instantly because it's part of the autonomic nervous system. That means you don't even have to think about it. I mean, your brain, if it suspects danger in any way, is going to send you into what we call fight or flight. That's called the stress response. And we'll talk more about the stress response when we get to that section in the book, but we're not there yet. The parasympathetic is what brings you down from that, gets your levels down. It works more slowly than the sympathetic system. So just a little bit of a review there. Autonomic nervous system happens without us having to do anything. Sympathetic, that's the emergency preparedness, fight or flight, raises all our temperatures, our heart rate, our breathing, amount of sweat, how we digest food, how we store food, and of course, stress levels, the cortisol, can actually lower our immune system. Okay. Parasympathetic is that decrease, getting back down to normal. Some people never make it to normal. Okay, let's go through the brain. We have two hemispheres of the brain, right and left hemisphere. They connect with a thick fibrous material called the corpus callosum. If we think of the brain as compartmentalized, there are different parts of the brain that have specific functions. And then we also use the term plasticity. The brain can work its way around. So if there would be some damage, say, to the temporal lobe, your brain, if it's been uh, active all these years, it's been working on its neural net, finding other ways, maybe not using those ways all the time, but finding other ways. And the person may not have any type of damage at all because the brain is very plastic. Kind of looks like a cauliflower, about the size. And each function of the brain is unique. They are not exactly the same. So let's look at the different lobes of the brain. So no, they're not really that color. Believe it or not, I did have a student ask me once if they were that color. So that's why I say this. It's not. So we're going to look at the occipital lobe, and the temporal lobe, parietal lobe, and the frontal lobe. So let's start with the back, the occipital lobe. That's visual processing. So if you're seeing right now this PowerPoint, your your occipital lobe is working. If you've ever had a concussion, you fell, you hit your head, if you blacked out and saw stars or like a flash of light, it's this part of the brain, the occipital lobe, that was damaged. Next, we move to the temporal lobe. So the temporal lobe's on the sides here, and that's language comprehension. So in other words, if you're understanding what I'm saying now, thank your temporal lobe. If you're hearing what I'm saying, thank your temporal lobe. If any of this information is new information, guess what? Thank your temporal lobe. And any new visual memories. So when I said, remember doing the wave, going back and thinking, oh, I did that in college, I did that in high school, I did that in grade school, whatever the time when you may have done it, that would be a memory that was stored by the temporal lobe. The parietal is on top. It's kind of like the crown part of your head. And attention and spatial location, knowing up and down, being aware of your surroundings, etc. The front of the brain is kind of the working king of the brain. It includes all our executive functioning. So it's right here up front. All our planning, all our motor skills, our memory, searches, reasoning skills, and it continues to develop until you're 25. And there was actually one research study that says men's brains continue to develop to 27, but it hasn't been replicated that I know of yet. So we're going to say 25 because that has been replicated multiple times. But that's also why your car insurance doesn't go down until you're 25. Because at that point, research shows the brain is formed. And this is all those executive functioning, reasoning, making good choices, knowing right from wrong, etc. And Phineas Gage, let's see, Phineas Gage was a railroad worker, and in the old days, in order to lay the rails, they had to use blasting powder to blow the holes so they could put the spikes in the rails as they were moving towards the west. And Phineas was a great worker. People loved him, never called off, just good guy. And one day, in order to dampen the explosion, they always put sand in with the blasting powder before they tapped it down. And Phineas forgot the sand. So when he went to tap it down, one of the rods, the spikes, literally came up through the back of his eye and out his frontal lobe. And that he survived in general is amazing. But he did survive. But they found really different personality traits going on there. So he was forgetful. He had issues. He actually got fired from his job. He had never missed work or quit. He was rude or swearing and screaming at his coworkers, which he had never done either. Uh, it was this part of the brain that was damaged, and it's why we believe that this is the home of our personality. Okay. This is the strips, and it's just a sample of what the different parts of our body are connected to what part of the brain. And you don't have to memorize these, but just pay attention here for a minute. If you look on the right side here, we have tongue, and we can go to the left side, and we also have tongue. And we can see right above that, like we have the lips, and go back to the other side, and we have lips, and we have eye over here and eye on the other side. But notice right here at the top, genitals. That's it. One place, nowhere else. So I make this point because there's certain parts of the brain that it is the only place that is controlling and directing different parts of the body. So if it would be damaged, there is no going around it. There is no plasticity that's going to make that work. Okay. Split brain research, good research paper topic. I won't give you the answer to it, but I'm also not going to test it for you right now. Towards the end, if nobody picks a paper topic with split brain, I will give you the information on it. But if we say this is the way that, the corpus callosum is the way that the two hemispheres communicate, If you would cut that hemisphere, you would expect that there would be a problem if you cut that corpus callosum between the right and the left hemisphere. And that's what the split brain research did. Why would they cut this in the beginning? Especially if someone had epilepsy, to make sure that the seizure didn't pass through to the other hemisphere. This is just what I like to call a reference point. At a college age, you should be able to know where the different parts of your brain are and your body. So I made a cheat sheet slide here to kind of help you out. Thalamus is the crossroads where everything goes through. The hypothalamus is what regulates your body temperature, typically at 98.6, but it can be like 97.0 to 99.7 or 8 for a range. For normal, you have to figure out what your is. And the best way to do that is just spend a week, like each day, take your temperature twice a day and record the data, and you'll get a good indicator of what your normal body temperature is. Hippocampus helps us to remember. The amygdala is the one we learn and use the most in psychology. The amygdala is our home of our feelings, our emotions, our motivations. It helps us to get into the limbic system, the old mammalian brain. Basal ganglia, that's what helps us to form habits and patterns. The brainstem is our wake up. In other words, that's what wakes us up in the morning, and the cerebellum is what helps us to walk on 2 feet. Again, another chart just to show you, you need to know where these parts of the body are as you get older. So if you do not, it's a reference. Again, I won't be testing you by giving you a blank body and you have to label the parts. I'll leave that for anatomy and physiology. But you should be familiar where your heart is, where your stomach is, all the basic important organs. There are 3 hormones that we talk about in intro to psychology. I kind of mentioned cortisol, which is the stress hormone. Estrogen and testosterone, both men and women have both estrogen and testosterone. Men tend to have more testosterone than estrogen, but they still have estrogen. So, we talk about women doing breast self-exams, shows men should do them too. It's more rare for a man to get breast cancer, but yes, they can get breast cancer because they produce estrogen. Women produce more estrogen on the whole. When a woman goes through menopause, there's less estrogen. If you have a complete hysterectomy, there's almost like no estrogen. They may put them on hormone replacement. The excess of testosterone, they may find hair on their face or like little mustaches or more under their arms or maybe even some chest hair, little bits. When we talk about how we didn't understand the science in the early days of the century, uh, people used to go to carnivals to see the bearded lady. Actually, the bearded lady probably just had a double dose of testosterone and not as much estrogen, but we thought of it like a freak show. She was perfectly normal except for that imbalance, and we just didn't have the ability to balance that out. There are drugs that can be taken, something like Estrotest, which is half estrogen, half testosterone, doesn't seem to have the negative effects as some of the estrogen replacements. And the pituitary gland is kind of the brains of the operation. When we look at the brain, where there are different ways to look at the brain. It's so much better now. It's not like a Christmas gift where you had to shake it and try to figure out what it is. We now have technology. We have EEGs that can read our brain waves. We have CT scans, which can see inside of our body, MRIs, PET scans, a visual function of an active living brain. We know so much more because we have the technology to do it. So if we have tumors, we have problems. If there are parts of the brain that are understimulated, they do have laser stimulators and laser knives that they can use. And people who have strokes don't, again, have to be old to have a stroke. But please be aware of certain signs of a stroke, speech pattern, we call it a word salad, where things aren't in perfect syntax, some problems focusing, and body movements may be limited because they can't move like their arm or their shoulder, or it's they're just kind of there. Get that person to an ER as quick as possible. And as I mentioned, we can stimulate the brain, we can do all that stuff. Okay, this next stuff is on Mendel and genetics, and I'm actually going to do a little bit of this in class itself. So I'm not going to, let me see how far we have to go. Yeah, I'm going to skip the Mendel stuff right now because I want to do that in class. There's an activity that goes with that, and I want to make sure we do that also in class. So I will do that in class. We talked about plasticity. Well, pruning's the same thing. It's the use it or lose it. So early development, childhood, you want to stimulate the brain of the child, and adulthood, keep the brain active so pruning doesn't take place. You know, doing anything to keep your brain active is important. When we talk about the twin studies, this is the big nature nurture debate. It's not a debate anymore. We know that it is equally nature and nurture. Actually, nurture wins out by about 7%. It's like 57% versus 43%. When we talk about identical twins, we're talking about monozygotic. When we talk about fraternal twins, dizygotic, that means 2 eggs, 2 sperms, okay? And the twin studies are an excellent paper topic too. So I'll leave that up to someone who may want to do that one. They had 2 gentlemen, they were twins, separated at birth, brought up in different parts of the country, never met, didn't really get to talk. They had separate, foster parents and then, adoptive parents. They finally got together through this twin study, and there were some things that were just uncanny. Their both first wives were Betty, second wives were named Anne. They both had a dog, and its name was Toy. They both worked as part-time sheriffs at McDonald's. They drove the same type of car. They went to the same beach for vacation every year, just 1 week apart. See what I mean by kind of coincidence? And they found this in many of the twins. So the twin study is really interesting. You may want to do that as a paper topic. And the last slide that I'm going to do right now is evolution in the brain. Genetic code is passed on. Really, really important, though, for genetic code to be passed on. That means you have to reproduce. Darwin's survival of the fittest means nothing if you survive but still don't pass on your genetic code. Those techniques, those survival skills you learned don't get passed on. So when we think of survival of the fittest, not only did you survive, an adaptation was made that helped to better your chances to survive. If you don't reproduce, it doesn't get passed on. So it's really important to remember that term. You'd be surprised how many times people forget that part of his theory. And that's it. So thank you for joining me today, and I hope you have a great day.